Hello. So, this is the first problem. In this problem, we have a 10-foot ladder leaning against a wall. The base of the ladder slides horizontally away from the wall at a rate of 2 feet per second, which is this dx dt down here, and it's going that way. As a result, the top of the ladder moves down the wall. At what rate is the top of the ladder sliding down the wall when the base is 8 feet from the wall? And this 8 feet here, that is our x. So we're going to want to identify our givens. We have x equals 8, our dx dt of 2 feet per second. We have our L of 10 here, and we have y, which is currently unknown, and dy dt, which is also unknown. We know that the rate of change is equivalent to the derivative with respect to time. So, in order to solve for the related rate of dy dt, we need to define the relationship between x and y using the Pythagorean theorem. So, x squared plus y squared equals L squared. We must then differentiate the Pythagorean theorem with respect to time to show the relationship between the rates before we can substitute the numbers, which we do d dt parentheses x squared plus y squared equals L squared equals 2x dx dt plus 2y dy dt equals 2L dL dt. In this case, though, this here, that is 0 because the length of the ladder is fixed. It is not changing, so dL dt is equal to 0, and you multiply that by the length of the ladder, and then you get 0. So now that we have all that set up, you can solve for y using the Pythagorean theorem and substituting in the known values. So 8 feet squared plus y squared equals 10 squared, or 10 feet squared. And then y squared equals 10 squared minus 8 squared equals 100 minus 64 equals 36. So then from there you get that y equals 6 feet. So now that we have that value, we can then substitute back into our derivative. So then you'd want to do 2 times 8 feet, or I'm going to move that over here, 2 times 8 feet times 2 feet per second plus 2 times 6 feet times dy dt equals 0. So then you get 32 feet squared per second plus 12 feet times dy dt, And then, that's all equal to 0. And then, from there, you get dy dt equals negative 32 feet squared per second over 12 feet. And plugging that into the calculator, you get negative 2.67 feet per second. And since it's negative, that indicates that the height of the ladder is descending at a rate of 2.67 feet per second. And if it were positive, the ladder would be sliding up the wall.